Metallic repair becomes necessary whenever damage or degradation threatens an aircraft's structural integrity. This could be corrosion pitting, dents from impacts, fatigue cracks around fasteners, or stress failures in high-load zones. If left untreated, these flaws can grow under repeated loads and environmental exposure and eventually compromise the airframe. Repair decisions are based on damage severity, the stress environment, and whether continuing service without action would violate safety margins. Not all repairs are built the same. Temporary repairs are stopgap fixes used in the field to make an aircraft safe enough to fly to a maintenance facility or until scheduled maintenance. Something like speed tape or simple patching to halt crack growth temporarily. In contrast, permanent repairs are engineered and certified fixes that restore full structural capability and are documented in the aircraft's maintenance and structural repair manuals. Temporary fixes are useful short-term, but permanent repairs are required before long-term operation. Common metallic repair techniques include patches and doublers, thin plates or reinforcement layers that cover the damaged area and are bonded or fastened to the original structure. These repair elements bridge the damage, redistribute loads, and slow or stop crack growth. In some cases, composite doubler patches are used on metallic airframes because they can be lighter, resist corrosion, and improve fatigue life. But metallic patching remains a core method when materials and access dictate it. Repair design isn't just about filling a hole, it's about how loads flow around the repair. When a patch or doubler is installed, engineers must make sure that loads aren't concentrated at new stress risers or fastener holes, which could lead to next-generation fatigue issues. Proper load transfer means designing the repair so the original structural paths are restored, or have an alternate path that meets strength and fatigue criteria by balancing stiffness and fastener placement around the damaged area. Aircraft structural repairs must follow approved repair data from OEMs or regulatory bodies. You can't just pick any fix off the shelf. Repair manuals, SRMs, and data sheets specify approved materials, patch geometry, fastener types, surface prep methods, and installation steps that have been validated through analysis and testing. This ensures that the repair meets engineering and certification standards and does not compromise safety or performance. Once a metallic repair is done, quality checks aren't over. Post-repair inspections verify that the repair was installed correctly, is free of defects like voids or misalignment, and that the surrounding structure remains sound. These can include visual checks, torque verification, and non-destructive methods like ultrasound or eddy current testing to ensure the repair characteristics align with the approved data and will survive in service. Documentation of these inspections supports continued airworthiness and ongoing trend monitoring.